All right. All right, let's start. Good evening, everyone, and welcome to tonight's lecture. This event marks the open keynote address of the ongoing international workshop titled Exploring the Layers of Digital Archaeological Practice. Held here at the NIA today and tomorrow, this workshop is the first in a 4-year series examining the impact of digital technologies on archaeology. For further details, please refer to the handout provided. When Marcus and I first discussed potential keynote speakers for this workshop, we immediately agreed that no one would be more fitting than Professor Kostas Kotsakis, a true pioneer in integrating digital methods into Greek archaeology already since the late 1970s. Tonight's lecture also holds special significance for Marcus and me. Professor Kotsakis has been our professor and enduring source of inspiration since our undergraduate years, profoundly shaping the academic paths that have led us here today. So we are deeply grateful to you for the effortless example that you have set to us and all your students. Now, the difficult part, how to fit Professor Kotsakis' achievements, into 5 minutes. Apologies for that. So Professor Kotsakis is an Emeritus Professor of Prehistoric Archaeology at Aristotle University of Thessaloniki. He is widely recognized as a leading expert on the Neolithic periods of Greece and Europe, as well as a central figure in advancing archaeological theory and digital methodologies within Greek archaeology. He completed his studies in archaeology at Aristotle University, where he also earned his PhD on doing Neolithic pottery from Sesculum. Notably, his groundbreaking dissertation was the first in Greek archaeological research to employ digital databases for the study of pottery. In addition to his tenure at Aristotle University, he has also taught at the Polytechnic School of Thessaloniki, the University of Thrace, and internationally at the University of Cambridge, Sheffield, and Stanford. He has also served as on the editorial boards of leading journals, including the Journal of Mediterranean Archaeology and the European Journal of Archaeology. Since 1973, he has directed field research at numerous sites, including Sesklo, Mandalo, Touba Thessalonikis, and most recently Paliabela Kolindrou in Pieria. He has also contributed to the excavations of Çatalhöyük in Turkey. Currently, he leads a groundbreaking project at the Neolithic lakeside settlement of the Spilio as part of the ERC-funded Explo initiative. This project employs cutting-edge interdisciplinary methods and technologies, including extensive dendrochronological analysis of hundreds of preserved samples. These efforts have significantly reshaped our understanding of the site's stratigraphy, biography, and landscape views. Beyond excavation, Professor Kotsakis has directed over 20-25 research programs on topics ranging from ancient technologies to archaeological site management. He has participated in what I believe are more than 100 international conferences and has organized many himself, including the 2002 EEAA conference in Thessaloniki. His prolific body of work encompasses more than 120 scientific publications. So I think you all got it. I could elaborate further, but on Professor Kotsakis' extraordinary academic contribution, transformative impact on Greek archaeology, and inspiring mentorship, but time does not permit that, apparently. On behalf of the workshop series organization board, I extend our deepest gratitude to Professor Kotsakis for honoring us with his presence and insights. So please join me in warmly welcoming our distinguished speaker tonight.
Well, thank you very much for this very generous introduction. I should say, ladies and gentlemen, but recently I found out that this is not permitted anymore. I don't know what we should say, but anyway, hello. Good afternoon to all of you. Now, I hope you will understand the message of my title, which is a bit peculiar, The Persistent Archaeologist, Jack of All Trades, by the, is it?
Right now. Try the phone now. still.
Right.
Uh,
Okay.
yeah,
Okay.
now it does.
Jack of all trades, master of none. Better than master of one. So the message is that over-specialization is not a good thing, but that's part of my lecture. Okay. My relationship with digital technology started in the summer of 1970, when, while waiting to board the boat to the island of Hydra to meet friends of the artistic community, I took a stroll in one of my favorite bookshops in the center of Athens. There on the table, I saw this book, David Clarke's Analytical Archaeology, displayed. I was immediately struck by the unusual, promising title, but my surprise became even more when I opened the book and browsed through its pages. I saw charts, tables, and histograms of the kind I had never encountered before in my archaeology readings of books full of photographs of sublime statues and vases without context, or the lectures I followed as a student. Looking at the contents and the bibliography of the book, I immediately realized that, to use a common expression, this was an aha moment when it occurred to me that there were possibly other archaeologists than the mainstream taught in the Greek universities then. This was clearly different from the mainstream in theory and maybe non-theory and practice, in that it did not avoid rigorous analysis of its foundational concepts and entities. Furthermore, it embarked on a systematic analysis drawing from computer science, geography, cybernetics, and statistics. Needless to say, I bought the book immediately. A few years later, when I embarked on a doctoral thesis, I was determined to apply a similar interdisciplinarity. In the meantime, I realized that Clarke's approach was influenced by the current analytical philosophy in Britain, and I had a different philosophical underpinnings. Nevertheless, I maintain an interdisciplinary orientation and a systematic definition of analytical concepts. I attempted to approach technology as a dominant social dimension of the Neolithic community and set up a methodology for studying it through pottery. This small historical introduction, for which I ask you to bear with me, perhaps gives a hint why I was invited to speak in this workshop on digital impacts on archaeological fieldwork. My encounter with Clarke's book was maybe an accident, but if nothing else, it put me on track from an early age, which I followed in my archaeological life. I will present some of these attempts to you today. Let me clarify from the start that I'm not an expert in computer science, so I will not bombard you with difficult to grasp esoteric concepts. I'm more like a restless field archaeologist who tries to define and treat archaeological data as clearly as possible. I admit that it was my young age rebellion against the vagueness and fuzziness of the concepts used by my professors in the history of ancient and modern art in my student years. At that time, I thought I was breaking a new path. Little did I know that this path has also its own impasses and obstacles. As an archaeologist with propensity for the field, I needed down-to-earth concepts that would not be adaptable to different researchers and views. I had already taken part in excavations carried out in an impressionistic way, meaning that it relied much on the impression of the excavator with no method that would present this impression as a result of logical, rational processing. I will discuss briefly some central theoretical points of excavation. To my mind, excavating a site, at least in principle, does not represent an opportunity for spectacular finds. It is more like a riddle, to be solved. Given that the site is a cumulative result of repeated human agencies, plus natural depositional and post-depositional processes, the riddle is formed by distinct entities linked to each other in a tight bundle. These entities are nothing more than the various deposits, the residue of human activity. We must identify them to make sense of the site. But how should we do that? Every archaeological handbook states that the stratigraphic evidence should be our first priority in excavation. While true, this statement is not very helpful, as in my experience, digging stratigraphically can mean entirely different things to different excavators or excavation traditions. This may involve, for instance, connecting the excavated deposit to a distant stratigraphy several meters away, considered representative of the site. Refer the excavated part by its assumed date or by architectural remains, or even using the strata concept, where each stratum has many layers, among other methods. In most cases, however, the geological element has been a firm basis for the excavation. The distinct layers, well, maybe I went one too far. The distinct layers of the deposit have to be identified, excavated, and thoroughly documented. These layers may be, therefore, the basic entities. In theory, each layer has to be dug in its entirety and represents one episode. So layers should be the minimum entity of excavation. As straightforward as it sounds, there are still certain issues with it. Occasionally, layers are hard to distinguish because of their physical characteristics or intense natural processes that have obliterated their borders. Unless a soil scientist is present in the excavation, this requires a very experienced excavator. On other occasions, a layer may extend to different excavation sectors. This may create severe logistic problems. But far from practical concerns, the main problem is feasibility. How sure can we be that these definitions of units correspond with the layers often revealed in running sections afterwards? So despite the emphasis on the objective geological aspects, the excavation details remain too abstract for a practical methodology to be built. One of my first assignments as a young archaeologist in the Museum of Thessaloniki in 1973 was to follow two excavations carried out by two foreign schools of archaeology, the British at Asyros, here, this, and the German in Kastanas, both near Thessaloniki. There, I had the opportunity to observe two very different schools of stratigraphic excavation. In Asyros, in Asyros, to the left, Ken Wardle applied an approach that later would become known as a single context recording, while in Kastanas, here, Bernard Hensel was excavating grid units to a standard thickness and dimensions, meticulously drawn in detail. The difference between the two systems was that the first relied on decisions taken during the excavation, while the second relied on post-excavation interpretation. I like the first approach because it obliged excavators to consider what they were digging. Still, I was skeptical about their ability to recognize the situation at the spot. On the other hand, I like the German idea of re-examining everything at the end by considering all the available evidence. Still, I wouldn't say I enjoyed the mechanical, detached way of executing the excavation, reducing everything to dry post-factum facts or data. Would there be a way to combine these two strategies and benefit from the pros of each one had without their cons? After years of experimentation with best excavation practices, I concluded that the way to combine the two strategies is to base the excavation recording on the actions and decisions taken by the excavator, the person digging. This is contrary to the determinism of a single context recording, which encourages characterizing the deposits beforehand while still digging them, so the recording is based on interpreted context. It's more realistic, and may I say more honest, than pretending to be an infallible excavator, or believing it, which is worse. Once this is accepted, the issue of the minimum entity takes a different turn. The excavator does not dig by definition real context, but rather a deposit on the sole condition that the digging does not cross any natural boundary horizontally or vertically. And you have here an example from Çatalhöyük. This is a house that was excavating in Çatalhöyük. And you can see here a darker shade. This is the unit, the excavation unit. And you see here a sketch, which, as you can see, includes this hearth here that you can perhaps see here. It may be arbitrary, or it may be within some recognized limits, or it may include an unrecognized boundary, like the hearth, and it may have any size or shape. The digger is alert for any site in the excavated deposit, indicating a later change. In all cases, the result will be a part in the deposit representing a minimum entity, which are called the excavation unit. It carefully records not the ancient activity. Oops, I have to get, okay. On the site, but the interventions and decisions of the archaeology. In other words, it separates the recording from the interpretation, which follows. This solution solves the problem of combining the two approaches pointed out just before, comparing Asyros and Kastanas, and leaves enough leeway to change the interpretation of the unit with relative impunity if the complete picture requires such a revision. Let us see how this can be done now. What you see here is one of the first attempts to actually deal with this problem. It's 1986, as you can see. This is something I did at that time based on a simple basic problem, program made in BASIC. And you see here what I mean with units. You see they are different shapes. Of course, it's schematized, okay? And here you see how you can actually make a section in this, in any particular place you like, any particular point in the trench. And this is the result of the units, which is one on top of the other. That's a wall here, okay? So this is a very simple, the first attempt to actually computerize this excavation process. Sorry. What you see in this slide is the units. We'll come to this later on when we discuss GIS. These are the units, one on top of the other, which are projected on the actual stratigraphy. And you'll see what this means in a while. Okay, modeling of the site is the next step. Modeling is a schematic reconstruction of the site with all the excavation units placed in their original location, like you see here. In this step, we try to reconstruct the site as a succession of events, which in this case will be the various excavation units. Imagine these units as 3D solids, like bricks of variable size, we come back to that, and shape removed by the excavation process. Then the post-excavation study will put them back in their original place, recreating previously in paper and now, of course, in computer, the interpreted site. So the idea is that you have all these 3D sizes, which actually form the excavated part, and then put them together in their real position. However, units are not only spatially dependent, they also have stratigraphic relations. Accordingly, three types of relationships between the excavation units can be observed. From superimposed deposits, earlier off, later than, belonging to the same deposit, contemporary, or being stratigraphically unrelated. These spatio-temporal relations are the core structure of the site on which all the finds are contained and all archaeological assessments are based. Of course, most of you have realized now that we are talking about a Harris matrix tool. And here is a Harris matrix, a very simple, very crude Harris matrix, which comes from Sesklo, and you can see all the sites, all the units sort of contemporary, because the excavation actually was done with horizontal layers in the German system of more or less the same thickness. So that's a very simplistic approach. And this is how Sesklo was excavated in the early 60s. Okay. In theory, Harris matrix aims to reconstruct the sequence of layers as they were deposited on the site. It reflects and sorts the stratigraphic sequence, so the oldest layer goes at the bottom of the matrix and the more recent at the top. But of course here, instead of talking about layers as the original Harris matrix dictates, we are talking about units, like we defined before. After all these steps are done, the only thing remaining to solve the riddle is the stratigraphic integrity of these events or units. The plan or the photogrammetric surveying of the stratigraphy is the primary reference here, projecting the sequence of units to the plan or preferably to its photogrammetric. You see Harris matrix here. This is from Çatalhöyük. Okay. And you see here the logic. This is a pit. The pit is here, so it's much earlier. That's the idea. Okay, this is an intrusive pit, so it's earlier than the rest of the. And these are all the units excavated in this house. Okay, projecting the sequence units to the plan or preferably. Okay, so let's move on. No. Okay. So projecting this, I don't know this. Okay, you see here in this slide, this is the same logic of what we did before, but it's made in CAD, so it's sort of 3D dimension. And you see one trench with all the units, one on top of the other. And then a section of this, which is relative to this stratigraphy, is projected on the section, on the bulk of the trench. So you can pick up whether the units are correctly dug correctly, or they cut different layers. So you can sort of pick up all those units which are correctly excavated, like for instance this one, from units which obviously are not, like this one, which have different things, includes different things. And that's a common mistake, a common problem in excavation, the integrity of units when they're excavated. And with this method, you can actually, and the idea is that if you have something, if you have a unit that actually is slightly mixing something, you can actually use the next unit, which is higher up, which is, let's say, clean, and you reject the other. While if you dig something without, as a complete layer, without separating, and eventually it proves to be mixed, it's completely useless. You have to throw it away because it's mixed with something which is earlier. So that's the basic idea. Here you see another very primitive example of dealing with these units, but the same principles are used now in the sophisticated CAD things, GIS things, as we've seen in the future. So here you have the units, how they were excavated, and as I said, you can project it and compare it to the stratigraphy. And here you have the actual units in the horizontal plane. So you can cut it either horizontally and see what's happening in a certain depth, or vertically, and you can see the stratigraphy and compare it to the actual real archaeological stratigraphy. It goes without saying that applying GIS in excavation is an obvious next step after that. After going from crude two-dimensional, let's say, plan or treatment to three-dimensional or semi-three-dimensional with CAD. Now the GIS is an obvious step. We will return to this step later on. However, before that step, the whole documentation process must be revised and adapted to this end. The critical thing to remember is that contemporary excavations aims to understand eventually, as much as possible, the actions of the people who created the site with their activity. The approach of single context documentation relies on pre-designed forms, like this one, that are filled out for each unit investigated. So this part here is filled according to a list of terms and descriptions, so that it's more or less standardized. And this is free text. Now I put in this red ellipse here. It's, as you can see, a kind of small part of the Harris matrix that eventually would become the bigger one I saw you before. So this is the unit excavated, and these are the, well, this is not complete actually. I didn't choose a good example. So these are the younger units, and these are the earlier units, okay? And if there are units which are the same as this one, you add them at the sides with the numbers. So let's sum up the steps forming the base of an excavation methodology as we discuss it up to this point. Step 1, documentation of excavation activity. Step 2, create a Harris matrix. Step 3, reconstruct the sequence of location of units. Step 4, create sections of units on selected planes, preferably near the actual stratigraphy, so there's no difference. Step 5, compare with actual site stratigraphy. Step 6, study archaeological material. So these are the basic things as I understand it at the moment. Now, let's see some of the very early attempts to actually deal with this complexity. These are from the early 80s, late 70s, early 80s. Of course, they are handmade. And I was explaining to before that these are made with letter set. Maybe the older from you remember the letter set thing. The youngest don't know what it is. I'll explain after the lecture. So these are all, and it's statistics from CESCLO indicating the percentages of painted pottery in different parts of the settlement. So this is one of the first attempts to actually do what Zafiri said before. And this again from another project of mine. Again, it's analysis. It's nearest neighbor analysis of post holes from a site called Mandalo in Macedonia, in North Greece, trying to identify, with a lot of post holes, trying to identify houses. And that's the result, again, drawn by hand. Of course, these are computerized, it's computer analysis, but the drawing is made by hand. And so you see a Bronze Age house here with a site in the middle. Quite realistic. I don't know if it's true, but later on I found out that nearest neighbor analysis is affected very much by the margin, as you know, probably. So if I had bigger area, or the whole area of the settlement, maybe the result would be different. But then it was nice. That's the good thing about these techniques. And this is a typical, I'm sure it's very familiar to you, the typical battleships, as they call them in statistics, of painted pottery at CESCLO, okay, in different parts of CESCLO. So it's part of my PhD. This was cutting edge at that time. Okay. Now, the next step in our, let's say, efforts with the excavation, with dealing with the excavation, was the using of CAD. And here you see CAD drawings. That's from Tumba Thessaloniki, it's a Bronze Age site. And these are pithoi. It's quite schematic, but quite useful at that time. And then you have the possibility in the CAD to, you see some photographs. That's the site as it was at that time. And here it's the trench at the site. And here are different phases. So you can actually use all these colors and identify identify the different phases. You notice that these are both the stratigraphies and the plans, as you see, are two-dimensional, okay? There are two dimensions. And so far, we could only use two dimensions. But of course, excavation is, a site is a three-dimensional thing. And unless you manage the third dimension, it's always, something is always missing. Again, one, let's say, that's the Tumba, sorry, the Tumba of Thessaloniki here. And this is just the reconstruction of the, with CAD of the relief of this, of the tell. It's quite quite high. It's more than 20 meters high. And then we moved further on by making reconstructions, reconstructions of the whole settlement. So this is the upper part of the settlement, and these are the sides of the tell with the constructions that hold the whole thing like a high hill. In fact, this was the first case when we realized that the tells are artificial things, not only because people actually are living on the same place and create that kind of hill, but because they take a lot of care for the preservation of the edge of the tell, so it becomes especially very steep, okay, very steep, and it stays in place. So it's major. We understood that it was a major technical work, massive actually, because the tube of Thessaloniki is quite large. Okay, but we have here a kind of 3D, pseudo 3D representation with the pots in situ, with the possibilities, the technology of the period. Again, the same thing, different versions, and another detail. Now, this is done by Marcos Katsianis in an effort, I won't try to explain it because only Marcos can, in an effort to create the 3D representation of the settlement. In fact, what is orange, if I'm not mistaken, Marcos, is what it would be 3D representation. And the rest are these obscure terms that actually CDOC CRM produces. So I won't explain, but it's just the first, let's say, the preparation for dealing with the three-dimensional GIS. Now, the actual GIS starts for photogrammetry. At the beginning, again, photogrammetry is two-dimensional, like this one. You see here, it's the camera. And then this is part of Pagliambela, and that's the actual plan here. So that was the first attempt to use, the first year to use photogrammetry in 2 dimensions. And here, according to Marcos, this is 2.5, 2.5 dimensions. I don't know what this means, but it's a pseudo 3D. It's not really, if I understand it correctly, it's not really a solid thing that actually you can move it from different sides. But they have with Spiros Tsipidis, who stands up here, up there, with his machine, takes the high points and actually creates this pseudo 3D, so we can accommodate the actual finds or the units that actually are excavated in this 3D physical substrate. Okay, now here is what we saw before. This is a pit, a ditch, a big ditch that runs around the settlement. These are the units which have been dug in this ditch, this yes, and you will notice that a lot of these units, which I remind you are arbitrary, they are not trying to follow the layers, are actually accurate. There are very little that can be, let's say, thrown away completely. So this was a good good indication that this system actually works. Now, once we move to the GIS, we can actually, because these all beautiful colors are all, and I'll stay here, are all units, different units, okay, in the same trench. And every example here shows a different thing. You can ask different the different qualities of the units. For instance, you can ask for moisture, or you can ask for dates, or like here are dates. Here are texture. You have clay, loam, and they change the color. The color changes according to the property that actually you're interested. Moisture is quite interesting because it may show, for instance, something which you would not find out, you will not observe while digging, that something is more wet. It has more clay, perhaps. There's a ditch which has been covered and it's not visible. So here you have stratigraphic levels and so on. So that means that every unit in the GIS system has a set of identities that accompany it together, in all its, let's say, in all its, in the system. So you have properties, you have objects, you have different objects, you have different properties, which are part of the unit. And this is how the whole thing works. And this is what we've seen before. Only here, the stratigraphy is not a plan, but it's the actual photogrammetric stratigraphy, which is the actual stratigraphy photo. And here you see the different units. And also you can have other sections which are different. This is, let's say, like 1 meter away from the stratigraphy, depending on what you want to see. You may want to see the stratigraphy inside the trench or near the bulk. And this is very handy. Also, you can have different units with different colors or textures, which is a possibility of the GIS now. So that makes more understandable, more readable, easier to read. Another thing which is obviously a possibility from GIS is actually to have the location of objects. These are plots. These are, I think, tools, if I'm not wrong. So you have the actual in 3D, the actual 3D position. And here you have the selected object, and it's photographed here. So it's very, very useful, very easy to use it on the study period, because you can have all the stratigraphic information, all the finds, and you can actually have the finds from the database of the system and proceed with the study. Again, the same, but what I want to show you is this, which is interesting. This is the process of the excavation, recreated. Okay, so see what sort of, which were the units that actually were dug over this is a burial, obviously, a pit with a burial. You have all the units that actually cover, and you can have them with the actual sequence that they were covered in screen. The same, I think it's here. Okay, these are the units. Oops, these are the units which were before, lower, and then the earliest phase. And I think so. You have that kind of information, which is very, very useful. And then complex shapes like this one, which is the beach we saw before, and then areas with different morphology, which are also excuse me, I have to find out. Okay. So if excavation is related to geology, GIS, as its name indicates, works with geography, another discipline that has had a formative effect on archaeology. GIS, more than any other, seems to be a fit for archaeological work. It combines the features of databases with their special references. It connects with maps, integrating location data with all types of descriptive information. This makes it an ideal tool for archaeology and allows archaeologists to see patterns, relationships, and geographic context in a way often impossible with traditional data analysis. However, there is a catch. In traditional archaeological research, place-time frames were considered nothing more than a backdrop of human cultural activity and its material expressions like settlements and objects. This common sense, intuitive approach was adopted early on from geography, ignoring the work of geographers such as Sauer, for instance, who were working on historical geography and human interaction with the landscape from the beginning of the 20th century. The space of GIS is an absolute Newtonian space that acts as a frame of reference and contains things and humans like a container. The issue is that this restrictive idea, automatically transferred through GIS, hinders the application of broader theoretical developments that have taken place in archaeology. Unconsciously, an archaeological argument set in this conceptual framework will be limited and constrained by the very nature of the theoretical premises of the GIS application. In the meantime, the concept of space of archaeology, I'm moving further. Yeah. Following the theoretical expansion of the discipline, has been transformed radically during the last decades. From the traditional space as a frame of reference and a container, it moved into Ian Hodder's space as a social factor. From the concept of space as a unified field of cultural presence, it morphed into Tilley's, Bender's, or Ingold's space as a lived experience. In sum, concepts of space have developed radically and in tandem with theoretical theory. Talk about space now has nothing in common with the understanding of space in the 60s or 70s, when the first ESRI GIS applications appeared. I'm not going into more detail about the space concept because this is outside the scope of this lecture. Space is a fundamental parameter of our understanding of the world around us and involves many aspects of contemporary philosophical discussion, which I'm afraid it exceeds my remit. I will limit my presentation to key issues of archaeology and space that I think deserve some attention. As we all know, post-processual archaeology became dominant in theoretical archaeology from around the 90s. Informed by postmodern philosophies, culture, for post-processual archaeology is primarily signification and should be approached as such. It climaxed to a point where the central analogy of culture was the text. As text, culture can be read differently by different readers. The correct reading is considered fiction imposed by realist and representational philosophies that go back to Descartes' philosophical foundation of modernity. The text analogy in archaeology, borrowed from postmodern philosophers such as Derrida and Foucault, transfers culture to a totally abstract level, detaching it from concrete actions of life. This perspective, which views culture as an endless web of immaterial meanings, raises concerns about the logical coherence of approach. You know, this famous Derrida's, there's nothing outside the text, which I think should be nothing is without context, which makes more sense. But I think it's, as others also have observed, is wrong translation. So this perspective, which views culture as an endless web of immaterial meanings, raises concerns about the logical coherence of the approach. Given the many possible interpretations, it directly questions archaeological reconstruction reliability. It challenges the connection between material culture and human action, suggesting that meanings are not inherently tied to objects themselves. This leads to relativism. It's like this famous prophetic sequence from the lady from Shanghai of Orson Welles, this genius cinematographer, where you have all these mirrors, but you don't know which is the correct, say, image, which is the real image. It's just reflections, many reflections, one after the other. This leads to relativism, where interpretations lack a solid foundation, echoing the arbitrariness of science in Saussurean linguistics. But that's for linguistics, not for archaeology. The theoretical debate thus reached an impasse, highlighting the limitations of post-processualism and postmodern philosophy in its archaeological applications. At the beginning of the 21st century, the reaction to this impasse came from various archaeological theoretical domains. One answer to the issue of the text analogy and the arbitrariness of meanings came to be rediscovering the 19th century philosopher Sanders Peirce and his semiotics. Peirce introduced what we now recognize as situatedness, supporting the notion that individuals engage with their environment, cultural and natural, in a concrete way. Situatedness underscores the significance of lived experience and everyday practices in comprehending culture, which helps us move away from systemic, functionalist, and postmodern approaches. Moreover, it explains how ascribed meanings are not arbitrary, but belong to three specific categories: indexes, icons, and symbols. The contemporary discussion has moved further along this line, integrating elements of the school of phenomenology of the 20th century, focusing on dwelling and biography of things. These new concepts also highlight the interconnectedness of people, objects, and their environment. Dwelling suggests that space is not merely a physical container, and this has some importance for what we are discussing, but a lived experience shaped by human activities and interaction. In a phenomenological world, space, objects are intimately connected to human activities. Space is a mode of proximity and availability shaped by human activities and concerns. This approach gives new meaning to objectivity by engulfing the practical engagement with objects rather than their conventional detached observation. By contrast, the traditional model, like the one utilized by GIS, cannot accommodate the experiential quality of space. Space is collapsed into a mere frame of reference, like a container devoid of the dynamic interaction between humans and their environment. And here you see perception of space, which is simply Newtonian space, where you have just lines moving in the map. The phenomenological approach to space recognizes the interconnectedness of people, objects, and their environment. Rather than dealing with the Euclidean hierarchies, as the example you see here, the phenomenological space is the rhizome created by the interconnectedness of people and things. And I underline "and things" because it's not only people who inhabit the world, but also things, objects. The perspective challenges the dichotomy between subjectivity and objectivity, proposing that making things available brings them into being in a social space, in the same way that the inert stone lying on the ground helps build a palace or a temple or a simple house through specific human agency. This approach offers a more nuanced understanding of space, emphasizing the lived experience and practical engagement with the world. Here is Latour, who is actually instrumental in this, and Tim Ingold with Meshworks. Again, a critique of this simple idea of space. Symmetrical archaeology, an archaeology that sees equally humans and objects. Philosophies of object-oriented ontology, the triple logos as it's called. And current material culture studies fill the space with active things. These observations become particularly relevant with GIS tools like distance and visibility, when they are used as proxies. This is a GIS application, an early GIS application of an area near Thessaloniki where we conducted a field survey. And this is a map that actually shows prediction of sites based on distance and other features. So when GIS tools like distance or visibility are used as proxies of relations between human groups, like here, that's a problem. While distance as geometrical measure is objectively determined, the measure of proximity in social space is the relationship of groups, not geometry. That reminds me that my pills. Βγάλ' το έξω, γιατί θα χτυπάει επί ώρα. It's just to take my pills, but I skip it for the moment. I hope I survive. As for the practical engagement with objects, Bruno Latour and contemporary materiality studies stress the non-human things are essential, not as abstract entities, but as living entities. According to Latour, considering space as a domain where only human cognition resides and objects are just a backdrop is an ontology created by modernity. In summary, contemporary theoretical discourse advocates for a shift towards a holistic approach in archaeology, which recognizes the interconnectedness of people, objects, and their environments. This approach challenges traditional space models and offers a more nuanced understanding of the archaeological record. Today, this is the challenge for really inclusive GIS application, together with time, but we are not going to deal with time now because I will take a long, long time. However, let me explain these last comments better to avoid misunderstandings. Do not assume that these concerns constitute a rejection of GIS in archaeological research. From its inception in the 1960s, GIS was not designed for archaeologists who deal with the complicated issues of culture, but for geographers, engineers, and developers. It is a valuable tool to measure and ask questions on things that can be measured, e.g., distances that have to be connected with modern highways, areas that will be flooded after the construction of a dam, or even after a heavy downpour. It is a valuable tool for the modern economics, a product of modernity, and is shaped on the concepts that the contemporary economy uses and functions, such as the commercial value of land, property rights, per unit prices, etc. Yet things become complicated regarding past cultures and peoples who perceive and give meaning to the environment and the objects that inhabit it. This lecture is a word of caution and a reminder that behind the smooth operation of algorithms, there are often hidden theoretical concepts that go back hundreds, if not thousands of years. Okay, last but not least, VR applications are now appearing shyly in museums and archaeological sites. They are bound to play a significant role in the communication of archaeology with its audience and the immediate future. Trying to reconstruct past lives in the detail faces the inevitable problem of missing evidence. Touching the limits of our knowledge about the past is a lesson in itself and demands some ingenuity in making educated guesses. I will show you in the with a few slides something of my recent experience on VR project at the Neolithic site of this Spilio in Castoria, where we tried to actually not just reconstruct the site, but apply all the evidence that we have from the analysis, which actually is currently towards its end. So we have information about all aspects of life from the plants that they were in the area, for what they were eating, what they were cultivating, etc., and many more details. So I'll show you some examples. So this is part of the village with the houses. The houses are built with these big posts, which survived, as you know, and were considered in the past as holding houses over the water, but it's not the case. And you see the houses with the thatched roofs, and you see an animal pen. These are all virtual reality, so you visit them with these special glasses, and you would go inside this thing. You'll be inside the Neolithic village. The village is accurate. Everything you see, the animals, of course, they are not alive anymore, but you see the animals they had. You see the pen in the place, in the location it used to be in the Neolithic. Everything is absolutely accurate. It's, of course, some things you have to, there are gaps always. You have to, like for instance, what sort of clothes they were wearing. Okay, we don't know what they were wearing, what clothes, but we can imagine. We can sort of make assumptions. These are the fields. The fields are very based on the evidence of the archaeobotany. So you have lentils and a kind of wheat, and the plants are according to the instructions of the archaeobotanist. And then you have people. The people do different things, like, for instance, they are cooking, or they are making pots, or they're making tools, and they talk. You met them, you see them, and they talk. They tell you something about their life. And this something is things we are sure we know they existed, but usually you don't see them in the museum, or you see a description of them in the museum. Instead of that, we have actual people talking to you. For instance, we have the hunter, the herder, the farmer, the lumberjack, the napper, the potter, the fisher, and the children of the village, and they all talk. They sing too, but I cannot play this here. So we call the people, we are talking this morning about outreach. We are calling people to visit the site, listen to the music, and listen Neolithic people talking. And I can tell you, because I've seen it with these glasses, it's quite impressive. Now, as a final, let's say, the dessert is. Πώς το διάλογο θα τελειώσουμε.
Είναι καλό ερώτημα αυτό.
Πρέπει να πάμε ένα παραπέρα. Εδώ είμαστε. Okay, this will be the next step. Δεν φαίνεται κάτι εδώ. Patience. I'm afraid you have to go to London.
Yes. Okay.
Let's make another effort, because I think it's worth the trouble. Αφού εδώ παίζει, γιατί
Δεν ξέρω.
diverted on that. Maybe people would like to see the painting and imagine, but it's very impressive. And I'm sure this will be a lot of things, a lot of things like that in the future in the museums. So it's not only virtual reality, that's one step ahead of the way from so that's the
Still, I can hear online they can see it. I don't know why I cannot bring it here. Online they can see it, but not here. Sorry?
It's on TikTok if you want to see that.
Okay, yeah.
Okay, you can see it in TikTok.
Yeah, I'm sorry.
Okay.
Yeah.
Can you just turn the computer on?
Okay, I could do that. Yeah. Nah, it's not easy with the cable, so. Yeah. Anyways. Νομίζω, ναι. Okay.
Okay, so that's it. Thank you very much.
We have some time for a couple of questions, right?
Oh,
So
sure.
thank you very much, first of all. So questions? Yes.
Thank you for an interesting presentation. And I kind of wonder, like with your long career and seeing all the changes, of course, within field archaeology and these kind of things, and ending up with speaking about symmetrical archaeology. And of course, what you didn't mention is our ontological friends, the artifacts and the material.
Sorry,
Or ontological friends like the material, other material world, stones and all these things. And particularly what I wanted to ask about was you're speaking about defining like context or layers whatsoever as a representation of past human actions. But of course, one of the difficult things in defining context, one thing is that we need a lot of skills to do that. And of course, with all as we go more and more like digital, as fast it goes to define this context. So maybe you lack something in the way you define it. And the other things is like the separation between context that is a representative of human actions and contexts that are post-exceptional processes and collapse and these kind of things. And
I didn't understand the difference between the two contexts.
The difference is that you're speaking about like we define the context as human actions.
Yeah.
And of course, like one of the problems is when you define the context, what's the part of the human action and what's the part when you define things about post-depositional processes?
Yeah, of course. Post-depositional processes are part of the deal, of course.
Yeah.
And this is something that you have to sort of take out from the beginning, take out from the record, and then what is left is the result of a human human action, human activity. We know that. I mean, we all know that the human activity is not intact. It doesn't. It's very rare that it survived as it happened, as it were. We deduce the human activity, and that's again another theoretical problem. Once we have taken out the effect of the post-depositional processes. I don't know if I answered your question.
Partly because on the one side, like we have like it goes faster and faster to define context due to tools we use. So I think we lose something because we are maybe like too fast to record them because we don't have there's a lack of skills like in defining context. What's the human imprint and what's the post-depositional things? Well,
my intention was to actually make clear that when the way we usually excavate by trying to define the context while digging is high risk method, because in my let's say career, I know very few people who would actually pick a context, what we call context in archaeology. It's a unit from the beginning without any mistake. Usually they would miss it. They would miss the unless it's something very obvious, which is the case. Sometimes is the case. So the method I try to describe is actually a kind of safety, let's say, measure in order to, if you lose something of the context, you still have what was before the to use. The idea is that you over divide the real context, let's say the physical context. You divide it and you dig it in several units, so that the contaminated unit, which might be next to another layer, can be discarded with less damage. If you dig the whole context at once, trying to dig it as one thing, and then is contaminated at the bottom, which is very likely, then you cannot separate the contaminated part. That's as simple as that. It's just a safety to actually be able to, the only let's say, complexity that have this system is that you create a lot of units. But there, that's what the computers actually can help you to solve, to sort out. Because rather than having one unit, which is, let's say, a real unit, you have 5 or 3. So the work becomes more, but the computers can actually sort this out. And the idea is that when you actually have defined the units that you think are intact, they are not contaminated, you can actually put things together and create new units that actually contain 3 or 4 of the former units. So that's the system. Is that clear?
Not totally, but I think I understand what you're getting. Yeah.
If I may, I mean, the units are not contexts.
Yeah, it's
we,
mechanical slices.
yeah, so
Yeah,
basically,
slicing, yeah.
the definition of context is takes place post-excavationally most of the time. So it's basically kind of a safety measure. It's better safe than sorry.
Quite right.
But of course, I can work in smaller surfaces, but they're large plans, like that gets more like highly complicated.
The other benefit of this method is that you can do whatever you like in the trench. You can dig a whole area or a small area, a small part, because it's, as I said, it's arbitrary. It's up to you. For instance, if you don't have enough time to dig a big area, you just split it in smaller, take every day each part as a different unit. So this is how it works.
But it will be the same context in the end.
Eventually, yes. I mean, you consider the same context. If you prove that something is different, you just discard it. You don't use it. Yeah, because I think a lot of the, especially in Greek archaeology, from my experience, a lot of the problems we have is because things were excavated in a very uniform, in horizontal splits, and a lot of things are, let's say, confused. I don't want to mention particular excavations, but there are excavations, published excavations, which are mixed. We know now, we see now that they are mixed. So this is a way to, this is the whole idea. It has a bigger, let's say, bureaucracy, but it's safe, I think.
Other questions? I have a kind of question both to you and to anyone who can reply. I mean, the last part, especially about the non-geometric qualities of space and how we deal with them, how we can feed them to the machine.
Yeah.
Any suggestions, you or from anyone else?
No,
How we build that?
I just tried to say that this idea of space that GIS uses, it's a very specific, as I said, a Euclidean space, a geometric space that has very concrete dimensions. It's okay if you just use it as it was meant to be, but if you are using this by applying the tools that GIS has to interpret things, if you start to interpret this space, then it's a problem, because this is not a Euclidean space. For instance, distance. You say this is near, this village is near the other village, therefore something happens because they are near. There's no near, and it is near if you measure it with our measuring perceptions in the present. But near or far can be a very subjective quality. For instance, people may go around because this straight line between the two villages is not permitted, or it's not sacred or whatever. Because space is also a concept that people have in their mind. It's not just a concept, a neutral concept. Neutral concept is space is something that was created in a particular point of time in the European thought. Otherwise, space is a dynamic entity. People have concepts about it, and this defines whether it's near, whether it's far, whether it's straight or not. Okay, they are not geometers. Geometers is something that was invented at some point, then forgotten, then reinvented in the Renaissance. And you can see it in the, for instance, take the painting of the Renaissance. In the Renaissance, the perspective suddenly becomes very important. The space becomes objectified in a way, and this is, let's say, the beginning of the modernity. But in the Byzantine painting, there's no perspective. There's as they say, there's a reverse perspective, rather than things going away to a point of whatever it's called, to one point. They are completely reversed. Why is that? They have a completely different idea about space in Byzantine. It's Byzantine painting. It's a conceptual thing. It's not an object. It becomes object. I would say, remembering my youth years as a Marxist, becomes an object to be exploited. To be sold, to be so it's not as simple as a map. Yes.
Thanks for your talk. I wonder what you think of the way that Frankfurt Cave was published, or is being published, where Jacobson sort of said every specialist can create their own stratigraphy, and so he didn't impose a context on it.
Frankfurt Cave, Jacobson.
Oh, right.
So every, when you read, let's say, the faunal analysis, their stratigraphy is different than the lithic analysis, and he sort of let each scholar choose what the stratigraphy was. I don't think he was thinking about this problem as deeply as you are, but he did worry about, people sort of imposing their idea of context on the evidence. Just curious what your feelings were about that, but perhaps.
Yes.
He called it multiple stratigraphies.
But you agree that stratigraphy is something very important, isn't it?
Yeah.
It's very important because that's let's say the history of the sites in a way, and therefore of human activity. No, I'm not talking about something abstract or I just for the question of stratigraphy, I just want to have the excavation conform to the stratigraphy. But because you don't know stratigraphy unless you excavate it, it's too late. When you find out what the stratigraphy is like, it's too late because you have already excavated it. Okay, even if you start from a section and going inwards, again, this is not safe because, of course, stratigraphy is not something level. So my talk and my idea about excavation is actually how to better control the stratigraphy.
I have another also, especially the last part with the virtual reality,
Yeah.
sort of really got my attention as well, because working with GIS, and you see this, I agree, this neutral perspective of space, this objectified space, which is very handy when you want to analyze something that was dug in different times by different people. You want to be able to play God, so you have this objective space. But then when you go to interpretation, you need to have this kind of relational, virtual kind of that you feel, a space that you can walk through and feel. And I always want to combine these two. And I was wondering whether, this is very good. This relative space is very nice to represent, to interpret, also use as a tool to interpret as well.
Sure.
But showing, looking at these images, I was wondering whether we could actually use the documentation and create a reconstruction of the process of excavation in virtual reality, and see how good we would do that based on the documentation we are having.
That's why I made this final, let's say, part, that this could be actually an excavation, a reconstruction of the excavation. Then you can at least find out the gaps you have in your knowledge. But the idea is that GIS is fine, is okay as a tool, but it's not an interpretive tool. It has been used as an interpretive tool. It's not an interpretive tool. It's just a tool to control, let's say, things that happen in space, in a neutral space, like in our space. But it's not interpretive as an anthropological instrument. If you want to interpret anthropologically, you have to go to anthropology and interpretive archaeology, whatever that is. You cannot do it through the, you should not do it, I think, it's my idea. You should not do it through the GIS. GIS is not for that. GIS is to predict things that will happen. For instance, as I said, a road or a dam or a flood or whatever. It's not to interpret, let's say, things that are related to human cognition. Because people have ideas, have beliefs, have perceptions, and that defines their life, not the distance. It defines our distance because we measure everything. But the prehistoric person didn't measure anything. He had no need to measure, let alone he didn't know how to measure, but he had no need. And the same holds for time. Usually you read the time consumption, how much time he needed someone to make. This is irrelevant for prehistoric people. They don't have a concept of time as a measure that actually they need to conserve. Yes.
Basically, you're mapping your practice in the GIS, not.
Yeah, I'm just. I'm not even a GIS person. I'm just, how to say, a user of GIS.
Would this reflect the system reflects your
no, because I don't use.
practice?
No, because I don't use it as interpretive. I use it as a tool. It's like having a hammer. You have a hammer to hammer nails. You cannot use it many other ways. I don't know, like killing your enemy. But I use it just to make order to the spatial units an excavation produces. I use it to have my finds located within the context, so on. But I don't use it for any other interpretive way. And this is what I suggested in my lecture.
One last question.
Can I have three?
This was Oliver Twist.
No, one is just a follow-up in this current discussion. First, I completely agree that GS should be, as it is, a tool. Like it cannot function without the human brain and the interpretive power of the archaeologist. And it should, on its own, remain as such. It's very powerful as it is, and it gives us what we need it for. Yet again, there are statistical techniques that combined with GS can help us model human behavior, especially if we know something about that human behavior. We can introduce cultural variables to a model or to a statistical technique that would provide us with various models that we could play with. Still, the decision is ours.
In that case, it's not just a tool of GIS, but it's a model. It's a model that has also some, let's say, anthropological
Absolutely.
dimension. In
And
that
that's
case, it
thank you.
might be different. It might be different.
And for simply recording practices, we should not let GS make the interpretive decisions for us.
Exactly.
I'm 100% on that page. Second, it's also as a comment, is not a question. I thank you very much for this very insightful lecture. It took us on a journey throughout possibly a lifetime of development and
Yeah,
documentation practice.
that's true.
And in the 70s and the 80s, you did something that nobody else in the region dreamed of.
So I hope I hope I didn't preach the initiated, as you say.
I have been personally following you for quite some time because my research was in Bulgaria. I did my master's and PhD on regional things, some of which were also Kastanas and
Right. Right. Okay.
And my question is, the first one is semi-serious, the second one is serious. What language were the people speaking in the virtual reality? And the
Of course,
second one is
because they're very, yeah, that's quite right. But I can play you the music they were playing.
that was going to be my second
It's
question.
through the
Do we
micro-
have evidence about the
Anyway, the
instruments?
language they're speaking is, of course, it addresses to the visitors, and they cannot speak Neolithic because no one would understand, not even the ones who wrote the text. So they speak Greek and English, and I think Russian, depending on the tourists that reach Kasturgan. They will speak all the tourists' languages, so they can follow.
And
Yeah.
the music, do you have evidence?
The
of
music,
that?
I have it on my phone. I can, if you're interested, you're not tired.
It's all
The music is based on the musical organs, instruments, excuse me, we found in the excavation. So it's the flute, it's a kind of whistle, it's of course a little drum, and then the human voice. Let me see if I find it now, because I wasn't prepared for that, so I don't know that you'd be interested in the musical aspect. No, I'm afraid I cannot find it. It's I don't know where it is in this. Apart from GIS, also I don't have good relations with this object, which you suggested we should use in excavations. Yeah. But I don't think I can find it at the moment. No. But if I find it, I send it to him.
So thank you very much. Thank you very much for your lecture.
You're very welcome.
Great
Thank you
having here.
for.
Thank you, everyone. And we continue with class of why.
Okay.